Bismillahirrahmanirrahim. We hope you are doing well. So today we are going to discuss something called uh, the gradient of a line passing through 2 points. That's basically the theory of 7.3. So what is the concept of gradient? In some books we also call this gradient as slope. So the word gradient and slope will have same meaning in this book. So what happens whenever we are given with any line? Let's say this is a line in xy plane. Suppose we have a line in xy plane. Let's say this is the line. Now what is happening on this line? Actually, on this line, as we are moving ahead, we are moving in 2 dimensions. 2 dimensions. What are those dimensions? One is x direction and the other one is y direction. So keeping this in view, we define the notion of gradient, or we say slope. So what is gradient or slope of a line that is passing through 2 points? Suppose this is passing through 2 points. Let's say this is one point A, x1, y1, and let's call this is another point B, that is x2 comma y2. So we are interested in looking at what is happening to the direction of y when we are changing an x. So we are interested in finding out the change in y with respect to change in x, roughly speaking. So we can say that change in y coordinate over change in x coordinate. So we call this thing as the slope of line or gradient of line. We represent it with m. So we are actually looking at what is happening in y when x is changing. So the ratio that is telling you change in y coordinate with respect to change in x coordinate, this ratio is the slope. So now this thing over here, this thing is x2 minus x1, and this thing over here is basically y2 minus y1. So we are interested in what is change in y with respect to change in x. So for a line, this change in y coordinate with respect to change in x coordinate remains fixed. So change in y between 2 points will be change in y, and this is going to be y2 minus y1, and change in x is going to be x2 minus x1. So the slope is going to be m equal to change in y coordinate with respect to change in x coordinate. So this is going to be y2 minus y1 divided by x2 minus x1. So what is going to be the formula for slope? The meta conclusion of this similar discussion is going to be the slope or the gradient of a line is given by m equal to y2 minus y1 divided by x2 minus x1, or maybe sometimes you can write it m equal to y1 minus y2 divided by x1 minus x2. There is no difference. Where what are y1 and x1 and y2 and x2? There are these are 2 points x1 y1 and b is x2 y2. Suppose you have a line that is passing through these 2 points, then the slope of that line will be calculated by either this formula or this, which is same, basically same thing, nothing difference. For example, I have got 2 points. Let's say this is my point A, which is 2 comma 3, and let's say I have another point B that is 3 comma 6, and I am interested in what is going to be the slope of line that is passing through these 2 points. We can look at the line. So 2 comma 3 is going to be 1 2, this is 1 2 3, so it is 2 comma 3 and 3 comma 6. So 3 is over here. Let's say this is 2, this is 3, so this is going to be 4 5 6, so this is somewhere over here. So this is going to be my line, basically this is the line. Sorry, I'm interested in what is the slope of this line, which is, or what is gradient of this line which is passing through these 2 points. So simply we will label these. This is y1, sorry, x1, this is y1, and this is x2, and this is y2. So my slope is going to be calculated by the formula that we have written, and it is y2 minus y1 divided by x2 minus x1. So put the values. So what is my y2? Y2 is 6 and y1 is 3, x2 is 3 and x1 is 2. So this is going to be 3 over 1, which is basically 3. So the slope of this line is 3. Our gradient of this line is 3. One more thing, the same slope, the notion of same slope is related with trigonometric ratio. Tangent, if you know bit of trigonometry, then you need to be a bit careful. If you don't, you don't need to be worried. Okay, so let's say we have a line that is going this way. Now let's say this has got 2 points. Let's say this is point A and this is point B. So we have already seen that uh, that this is y2 minus y1 and this is x2 minus x1, or simply this is change in y and this is change in x. This thing is change in y and this thing is change in x. So the angle that line is making over here, theta, is same with this thing, theta, over here, and we know that tangent theta is equal to perpendicular over base, and the perpendicular in this case becomes this and base becomes this. If you know trigonometry, then this is perpendicular and this is base. If you don't know trigonometry, don't worry. So this is again what? This is slope, which we have already defined. So this means that the gradient or the slope can also be the tangent theta, measure of theta by tan ratio. Okay, so let's move ahead. Indeed, there are some specific cases too in this discussion. For example, if I consider 2 points, let me call point A, which is 2 comma 1, and let me call point B, which is 5 comma 1. I'm interested in the slope of this line. Let's see how this line looks like. So 2 comma 1 is going to be 1 2, and what is going to be my y? This is 1. So the point is over here. This is my point A. 5 comma 1, this is 3 4, this is 5. 5 comma 1 will be this, so the line should be this one. We can see that if we plot the line that is passing through given 2 points, these two, then line is parallel to x-axis. Let's try to calculate the slope of this line. It's going to be xy, so let me call this x1, let me call this y1, let's say this is x2, and let's say this is y2. So y2 minus y1 is 1 minus 1, x2 minus x1 is this, which is 0 over 3, and which is 0. So that means if line is parallel to x-axis, or we can say that line is horizontal, then slope or gradient is equal to 0. Okay, on the same lines we have got another example. Let us consider two other points. Let me fix the a same, which is 2 comma 1, and this time I will call another point C, which is 2 comma 5. Let's try to plot this as well. So what is going to be my point A? Where is going to be my point A? This is 2 comma 1, so this is my point 1, this is 2, so 2 comma 1 is somewhere, this is my 2 comma 1. Where is 2 comma 5? So the x coordinate is same, but y is 5. 2 3 4, let's say this is 5, so this is over here. So this is point A and this is my point C. So the line should look like this. Now this line is vertical, I mean this line AC is vertical, or you can say that it is parallel to y-axis. Line is parallel to y-axis, or you can say that line is vertical. Let's try to find out the slope. Let me call this x1, y1, and this is my x2, and this is my y2. So y2 minus y1, and then x2 minus x1, 2 minus 2. So it's turns out that's 4 over 0. Since we are in real numbers, so we are not allowed to divide by 0. So therefore we call, if line is vertical, then the slope is not defined. We don't define this kind of species, so slope is undefined. Slope is not defined for this case, so it's fine, we are happy. Okay, so let's move ahead. Therefore, whenever you write the definition of slope, that is y2 minus y1 divided by x2 minus x1, we usually say that this slope is defined for non-vertical lines. In other words, x1 and x2 are not equal, because if x1 and x2 are equal, then line becomes vertical and slope becomes undefined. So the slope is defined for non-vertical lines. So far so good. One more thing that I'll not going to prove, but I'll state it over here, that you need to discover by yourself is, if the slope is negative, then angle between line and x-axis is obtuse. What do we mean by obtuse? An angle with measure obtuse means angle with measure greater than 90, and if the slope is positive, then it becomes acute angle, means less than 90. if slope is positive, and if slope is